So these steps, we had them on Thursday. They're the steps for solving these radical equations. Our first main step is there on radical. If so, get it by itself. If not, even them out. So if we look at this here, do we have one radical? Yes. In this equation, the only radical we have is the square root of x plus 6. So we need to get it by itself. Well, luckily for us, it is indeed by itself. So that means we can put both sides to the nth power, our second step. And our nth power in this case is 2. And the reason we do this is to simplify that radical out, because the square root squared simplifies out. They cancel out. They undo each other. Now on the left-hand side, we have x being squared. Bless you. And it's just the x term, so we just have x squared. Step 3, are there any radicals left? No. Because if so, if there were, we're going to repeat steps 1 and 2. Since they're not, we can move on to step 4, which is just to solve. Solve for the variable. Now, everything we did on Thursday, it was pretty much get x by itself solved. And that's because we did not have x to a power greater than 1. Here we do have an x squared term. Yes, we need to get everything on the same side. We need this equal to 0. And then factor. So we can subtract x from both sides. Notice that x squared minus x is equal to 6. Minus 6, telling us that x squared minus x minus 6 is equal to 0. Now at this point here, we can factor. Always, our first step of factoring is finding the greatest common factor. If there's a number or term that can go into all three, and well, there's no greatest common factor here. Since the third term is negative, our signs are opposite. Factors of the first term, factors of x squared, all we have is x and x. Factors of 6 are 1 and 6 or 2 and 3. And we'll use 2 and 3. Because if we check this here, we want a middle term of negative x. X times negative 3 is negative 3x. 2 times x is positive 2x, giving us the negative x middle term that we wanted. Now, since we do have two things multiplied together to equal 0, one of these is going to have to be 0. Either x plus 2 is 0, or x minus 3 is 0. We can set both of those equal to 0 to solve for x. Now with our x plus 2, to get x by itself, we can subtract 2 from both sides. Telling us that one of the solutions for this here is negative 2. Our other one, we're going to add 3 to both sides. Telling us that x is equal to 3. Now we're going to check just to make sure, because our original equation, x is equal to the square root of x plus 6. We just want to make sure that both work. So if we start with 3, we'd have 3 is equal to the square root of 3 plus 6. Well, the left-hand side of this equation, we just have 3. On the right-hand side, we have square root of 3 plus 6. We can do that by hand, or we can just say square root 3 plus 6 is, lo and behold, 3. So that tells us x equals 3 is a solution. We can do the same thing with -2. Now, on the left-hand side of this equation, we drop the parentheses and we have -2. I'm going to work this one out so we can see it. -2 plus 6 is 4, and the square root of 4 is 2. Well, -2 is not equal to 2, so that means x equals -2 is our extraneous solution. It doesn't work. So especially problems like this on the test, I'm going to want both solutions. Even though -2 doesn't work, I still want it. Because again, when we go through and solving, we should get both solutions. One of them works, one of them doesn't. Does that make sense? Questions on this here? We're good with this here? And the main reason this comes, we get this -2, is from this second step, from squaring it, because -2 squared is 4. 2 squared is 4, so we get both of those possibilities. Only one of them actually works, but we do get 2 from it. Okay, let's look at another one. X equals the square root of 20 minus x. There is one radical. Luckily, it is by itself, so we can go on to step 2 and put both sides to the nth power. Well, the nth power in our case is 2. And again, just like the last one, square root and square will cancel, leaving us with 20 minus x on the right. On the left-hand side, we just have the x term, and when we square it, we multiply by itself, we do get x squared. Now again, anytime we get this x squared, this term, this variable to a power greater than 1, we have to get the equation equal to 0. So the first thing we can do here is add x, because our -x plus x is going to cancel. On the left-hand side, x squared and x aren't like terms, so we just have x squared plus x equals 20. Again, at this point, we can subtract 20 from both sides. Telling us that x squared plus x minus 20 is equal to 0. Now at this point here, we can factor. We need to find out what values of x are going to make this thing equal 0. Now since the 20 is negative, our signs are going to be opposite. Only factors of x squared are x and x. Now our factors of 20 are 1 and 20, 2 and 10, 4 and 5. 5 and 4. 5 and 4 are going to be the one that we're going to want, and since it is positive, we probably want the 5 to be the positive number. And if we check this to make sure we factored this correctly, x times -4 is -4x. 5 times x is positive 5x. So -4x plus 5x is indeed positive 1x. That is the middle term that we wanted. Zero product property. Anytime we have two things multiplied together to equal 0, one of these two is going to have to be 0. Either x plus 5 is 0 or x minus 4. So we can go through our process, our steps for solving these equations here. And it tells us that x is either -5 or x is 4. And specifically with these here, especially when we have a variable outside of the radical, when we start squaring and solving, we're definitely going to have to check those. Because if we look at negative 5, because we'd have negative 5 is equal to the square root of 20 minus negative 5. Our negative 5 on the left side of the equal sign is just going to be negative 5. We could type this into the calculator. 20 minus negative 5 is the same as 20 plus 5. 20 plus 5 is 25. Well, the square root of 25 is positive 5, not negative 5. So x equals negative 5 is an extraneous solution. It does not work in the original problem. It is a solution that we get from solving, but it does not work in our original context. Most of the time, not always. Because if there was some way for us to offset that negative, then it would possibly work. Yeah, and I can show you that here in a second. Because if we check this one here, 20 minus 4 is 16, square root of 16 is positive 4, that works. So this is our only solution. Now, I'm going to change this problem just a little bit. And what I'm going to do is this. I'm going to say negative x equals the square root of 20 minus x. Funny enough, this actually doesn't change a whole lot. Because here we would square both sides. And negative x squared, negative x times negative x is positive x squared. So that holds true. All that holds true. All that changed was that now we're saying that negative x is equal to 20 minus this x, square root of 20 minus x. Well, if we look at 4, as we already saw, the right-hand side, 20 minus 4 is 16. Square root of 16 is 4. Because that negative outside, it turned it from positive 4 to negative 4. Now the positive case doesn't work. Let's see what the negative case would be. Well, that'd be negative 5 is equal to the square root of 20 minus negative 5. Here, the negative is going to make it positive. 20 minus negative 5, bless you, is the same as 20 plus 5, which would be the square root of 25, which is 5. So if it had been negative x on the other side instead of positive x, the negative case works, the positive doesn't. In our original context, the positive worked, the negative didn't. So there are some cases where the negative is the correct answer, the positive isn't. But if we look at this one here, the negative is not going to work. Because if we look at this other side, it's just x. It's x by itself. There's nothing that's going to change it from negative to positive. And we know an even root, the square root, we cannot have a negative number come out of it. So there's no way an even square root or an even root can equal a negative number. But does that make sense? Square root of 4 minus 3x equals x. We do have one radical. It is by itself, so we can go on and put both sides to the nth power. And the nth power in our case is going to be 2. So when we square both sides, the left-hand side, the square root and square will cancel, giving us 4 minus 3x. On the right-hand side, we do have x squared. Now again, since we have a variable to a power greater than 1, we have to get it equal to 0. Power greater than 1, and we do have a variable to the first. So we can add 3x to both sides, because negative 3x plus 3x is going to give us 0, leaving us with just 4. X squared plus 3x is exactly that, x squared plus 3x. Again, we still need to get this equal to 0, so we can subtract 4 from both sides. Telling us 0 is equal to x squared plus 3x minus 4. And again, just like before, we can factor this. Third term's negative, so the signs are opposite. One is going to be positive, one is going to be negative. Only factors of x squared are x and x. Now our factors of 4 are 1 and 4 or 2 and 2. Now we're going to want 1 and 4 for this here, and since the third term, or not third term, but the middle term is positive, we would want the bigger of the two numbers to be positive. And again, just like before, we can check this here. X times negative 1 would be negative x. 4 times x is going to be plus 4x. Negative x plus 4x is positive 3x. Now, since we do have two terms being multiplied together to equal 0, one of these is going to have to be 0. Either x plus 4 is 0, or x minus 1 is 0. Again, solve for x. Get x by itself. We can subtract 4 from both sides, telling us x is negative 4. And we can do this because, again, in both of these terms, x is to the first power. X does not have a power greater than 1. We can just get x by itself, and that's our solution. So the two solutions that we have for this here is that x is negative 4 and x is 1. Another way we could have gone about solving this here is graphing. X squared plus 3x minus 4. We can graph it and see where it crosses the x-axis. Second table does give us the table. And when we graph it, our solutions, or whatever value of x, will make the y value be 0. So at negative 4, the y value is 0. At 1, the y value is 0. So it does give us these two solutions. We just need to check. Most likely, the negative 4 is going to make our x square root of 4 minus 3x. Going to make that be 0. So if we check negative 4, so we'd have the square root of 4 minus 3 times negative 4 equals negative 4. Now, on the right-hand side, we do have negative 4. Now, for the most part, we've been doing this by hand, but we can do this in the calculator. 4 minus 3 times negative 4 gives us, lo and behold, 4. But 4 is not equal to negative 4, so it's an extraneous solution. It doesn't work. With our 1, we can do the same thing. 4 minus 3 times 1 is equal to 1. Four minus 3 times 1 would be the square root of 1, which is 1. 1 is indeed equal to 1. So the one solution that does work is x equals 1, or x equals negative 4 doesn't work. It's not always going to be the case that both don't. One doesn't work, because it could be that both work, or it could be that neither one of them work. Doesn't always have to work out. Questions on this here? All right. Let's look at this next one. Solve 13 plus the square root of 5n equals 3. So we have this equation here. Do we have one radical? Is it by itself? No. So just like the previous ones, we still just have one radical, but it is not by itself. So the first thing we have to do before we start solving is to get that radical by itself. We can subtract 13 from both sides. And we subtract 13. On the left-hand side, we're going to be left with the square root of 5n. On the right-hand side, 3 minus 13 is going to be negative 10. So now is the radical by itself? Yes. So now we need to put both sides to the nth power. And again, in this case, we're going to square. Now on the left-hand side, the square root and square would cancel, telling us that 5n is equal to negative 10 squared. Negative 10 times negative 10 is 100. Questions on any of this so far? Now we need to solve for the value of n, and to do that we would divide both sides by 5. 100 divided by 5 is 20. Telling us that our solution, our value of n for this here is 20. Before we call this good, we'll go on and check. "13 plus the square root of 5 times 20 is equal to 3. Well, 5 times 20 is 100. What times itself is 100? Well, that would be 10. 10 plus 13, 13 plus 10 is 23. Is 23 equal to 3? Well, no. So what does that tell us? N cannot equal 20. Do we have any other solutions? No, so this here is no solution. There is no solution that works for this here. I'm going to back up to this here. So we said the square root of 5n equals negative 100. We went over this in chapter 5, chapter 4. The square root can't equal a negative number. We cannot find a square root of a number and it be a negative number. This just does not work, because the square root of any number is going to give us either 0 or a positive number. Because we came into the same issue with trying to find what times itself equals negative 1. Well, we figured out that x had to be I. And it's kind of different. It is different. But here, this square root of 5n, even if we look at it graphically, second square root, we'll call it 5x, does not drop below the y-axis. It cannot be a negative number. There is no number that we can take the square root of and be a negative. It just does not work. That's part of the reason we get this imaginary or no solution for this here. Because we're saying for this next one, 3 times m, square root of 3 times n, plus 10 equals 1. Only one radical, so we need to get it by itself. We can subtract 10 from both sides. Well, we're here, we're saying that the square root of 3m equals negative 9. So we're saying we're multiplying something by m and ending up with a negative number, or the square root of it's a negative number. This is not possible. There's no way to take the square root of a number and get a negative, an even number, and get a negative. Because we can go through the process here. We can square both sides. Square root and square would cancel, telling us that 3m equals 9 squared is 81. Point here, we can divide both sides by 3, telling us m is positive 27. And again, when we check it, 3 times 27 plus 10. Well, 3 times 27 is still 81. Square root of 81 is 9. 9 plus 10 is 19. And we were saying that this equation had to equal 1. None. No solution. So we're going to solve this, check for our solutions. P plus 1 is equal to the square root of 7p plus 15. So again, let's keep going through our steps because our steps are going to be the main thing for this here. Is there one radical? Yeah, so get it by itself. Is the radical by itself? Yeah. So we can put both sides to the nth power. Now the right hand side for this is going to be kind of nice because the square root and square will cancel, leaving us what was inside our radical, which is our 7p plus 15. Now the left-hand side's a little bit different. We can't just square the p in 1. Because we have two things being added, we actually have to multiply p plus 1 by itself. We have to multiply p plus 1 by p plus 1. We have to FOIL this out. Now the first product, the p times p, would indeed give us that p squared. But we also have p times 1. It's going to be positive 1p. Now our 1 times p is going to give us plus p. And lastly, 1 times 1 gives us 1. Combine like terms. Now again, we do have a squared term and a middle term, so we do need to get this equation equal to 0. So the first thing we can do is subtract 7p from both sides, telling us that p squared minus 5p plus 1 is equal to 15. Then we can subtract 15 from both sides, telling us p squared minus 5p minus 14 is equal to 0. Questions on how we got to this point here? Now at this point here, because the number in front of p squared is 1, we can actually graph this and get our answers. As we'll say x squared minus 5p, so 5x, minus 14, and hit graph. Now we see that this does intersect at two nice spots, because if the number in front of the squared term, our p squared here, x squared is 1, if it's going to have nice solutions, our integer rational solutions, they're going to cross the x-axis at integer locations. If we have a number in front of our x squared term and no greatest common factor, we're going to have possibly integer solutions. Well, here are the two solutions, values of x, that make this function be 0 are when p is equal to 7 and p is equal to negative 2. Or when we typed it in the calculator, we were talking about it in terms of x, but p is the same thing. And again, just like we've seen several times today, we would definitely need to check this here and make sure that this works. We need to plug these values back into our original equation. P plus 1 is equal to 7p plus 15 to make sure that either one, both, or neither of these work. We need to see which ones work. Now, out of the two of them, as we've seen so far, the positive case is the one that normally works. So we can try 7 first. On the left-hand side, we have 7 plus 1, which is 8. On the right-hand side, we have 7 times 7, which is 49. Square root of 49 plus 15. 49 plus 15 is going to be 64. And the square root of 64 is indeed 8. 8 equals 8, so P equals 7. This is a solution. It does work. We'll do the same thing with negative 2. On the right-hand side, we'll do it first. 7 times negative 2 is going to be negative 14. Negative 14 plus 15 is 1. Square root of 1 is indeed 1. On the left-hand side, negative 2 plus 1 is negative 1. Negative 1 is not equal to 1. So the only solution we have here is that P is equal to 7. Questions on this here? Questions on anything we've done so far? All right, 26. B minus 6 is equal to the square root of 18 minus 3b. We have one radical. It is by itself, so we can go on in, put both sides to the nth power. Well, again, in most of the ones where we do have more than one term on the other side, we're only going to be looking at second powers. Cubes and higher are solvable this way. It just makes the other side a little more complicated, or just a little more we have to do to solve, not so much complicated. Because when we square this, b minus 6 squared, we're going to have to multiply that out. Now, there are ways to go through and multiply it out. We could use the fact that this is the same as a minus b squared, which according to the formula is going to be a squared minus 2ab plus b squared, and type in a and b, or plug in a and b in their corresponding spots. Or we can just multiply it out. Because if we multiply this out, b times b is b squared. B times negative 6 is negative 6b. Negative 6 times b is negative 6b as well. And negative 6 times negative 6 is going to be plus 36. Negative 6b minus 6b is going to be negative 12b. Giving us this here. Now again, we do have a b squared and we do have a b term to the first power. We will definitely need to get this equation equal to 0. So the first thing we can do is add 3b. Telling us b squared minus 9b plus 36 is equal to 18. Then we can subtract 18, telling us b squared minus 9b plus 18 is equal to 0. Questions on this here? Is there a greatest common factor between these three terms? Between b squared, 9b, and 18? No. Is the number in front of b squared different than 1? No, it is 1. So that tells us we can graph this. We should be able to graph this and get nice solutions. And when I say nice solutions, I mean integers, non-fractional, non-decimal solutions. So we'd be able to graph it and get nice numbers. We can graph it and get the solutions. And we wouldn't type it in as b squared or b. We can just say x squared minus 9x. I think it was minus 18. Plus 18. And we can graph this here. And it does give us two nice locations where it does cross. Second graph, the two values of x that will make the y value be 0 are 3 and 6. So that tells us that b is equal to 3 and b is equal to 6. b minus 6. b minus 6 is equal to the square root of 18 minus 3b. We're going to check both of them. Which one do we want to check first, 3 or 6? 3. Now they're both positive, so it's showing us, and as we've seen so far, that both of these should probably work. The right-hand side, I'll deal with the radical first. We have 18 minus 3 times 3. Well, our negative 3 times 3 would be negative 9. 18 minus 9 is 9. Square root of 9 is 3. Really, if y'all wanted to, especially on the test, I'd take square root of 18 minus 3 times 3. In the calculator, hit enter. It'll tell us that it is 3. 3 minus 6 is negative 3. Negative 3 is not equal to 3. So b equals 3 is an extraneous solution. Even though it's positive, it still did not work. Let's do 6. Left-hand side is kind of nice here. 6 minus 6 is 0. On the right-hand side, 3 times 6 is 18. Well, 18 minus 18 is 0. Square root of 0. 0. Because 0 times 0 is 0. So even though we got 0 equals 0, that is still a true statement. So b is indeed 6. And that's it. So even here, as we saw earlier, see it again here, just because it's a positive solution doesn't mean it is the correct answer. It's not going to be a given. We do need to check them. 23 or 22, which one do y'all want to look at? Last problem of the day. '22. Other direction. Here we go. Negative n plus the square root of 6n plus 19 equals 2. Now, do we have one radical? Yes. Is the radical by itself? No. So to get it by itself, we would have to add n to both sides. Because our negative n plus n will simplify out, leaving us with the square root of 6n plus 19 on one side. The other side, 2 plus n plus 2, really doesn't matter how we write it. We can say 2 plus n or n plus 2. They are the same statement. I like putting in our variables first and decreasing by power. Now we do indeed have the radical by itself, so we'll put both sides to the nth power. And on the left-hand side, the square root and square would cancel, telling us that 6n plus 19 is equal to, well, n plus 2 times n plus 2. We're multiplying it by itself. And we will have to multiply that out. N times n is going to give us n squared. N times 2 is going to be plus 2n. 2 times n will give us plus 2n, and our 2 times 2 would give us 4. Before we start getting this equal to 0, we will need to combine like terms. So we can finish combining like terms, we still have n squared. So we will get this equal to 0 first by subtracting 6n from both sides, telling us 19 is equal to n squared minus 2n plus 4. Then we can subtract 19 from both sides. telling us 0 equals n squared minus 2n minus 15. And again, no greatest common factor. Number in front of that's not plus is 1. N squared minus 2n minus 15. So it might help if I have 2 instead of 3. And we graph it, we do get this here. And we look at the table. Our two values of x, or n in this case, that give us a y value of 0, are negative 3 and 5. So we do have two values here. And our original equation was negative n plus the square root of 6n plus 19 equals 2. And if we check with negative 3 first, negative 3 plus the square root of 6 times negative 3 plus 19 is going to equal 2. Negative 3 is going to be 3. 6 times negative 3 is negative 18 plus 19. Negative 18 plus 19 is 1. Square root of 1 is 1. Well, 3 plus 1 is not 2. 3 plus 1 would give us 4. So that tells us negative 3 does not work. Now we can redo this. Instead of having negative 3, we can have 5. So negative 5 plus the square root of 6 times 5 plus 19 equals 2. Now, I'll do this here probably like the way that y'all would do it on the test. Plus 19. We can type the whole thing in. It indeed tells that 2 is equal to 2. So the only solution that worked for here, that is if n is equal to 5. And that's it.